guys. Today this tutorial will show you how to install an extra reset slice on the CNC router machine. Before going to the reset slide, let's see the router machines. This is high reset 400 model. That means it has X direction travel of 400mm. As many people know this, when using this type of these companies made CNC router machines, the rear portion of the table cannot be accessed by the spindle. That means you cannot put workpiece on here for machining. Even though when you mount a T-slot table and you want to do some precision machining, you need to fine finish the top surface once. So how can you finish this portion? That's a question. This tutorial will introduce make an extra reset slice on this rear. The original reset slice is here. My T-slot table is already been machine set before I have this extra reset slice. During the machining of this top surface, I make a lot of difficulties. I need to swap this spindle with the reset slice whole assembly to here. It's possible for us to do so because the mounting screw hole is grow through here. Let me bring the camera. You can see there are 4 screw holes, so the whole reset slide can be mounted here at lower level or higher level. And after you dismount this whole reset slide, all the perpendicularities and straightnesses are gone. When you put back on the front, you have to line it up again precisely, so it is troublesome. Before putting on the reset slide on the back, here you need to make a long aluminum board here. In later tutorial, I will show you how to make this long aluminum board and what purposes of it, instead of for the mounting of the rear reset slide. There is other purpose of making installing this long piece of aluminum board here. Here is a THK linear actuator. This is a ball screw tab, and the length of ball screw is around 190, and the total length of this is KR20, and total length is 10 inch. I bought it on the eBay, and it is a used one, but when I received it, it's almost brand new. I was quite happy of its conditions, and the cost of it is cheap. It's around 200 US dollar, 200 to 250 US dollar, and it also incorporates with the couplings there. The travel is very smooth, and all the construction is very rigid, strong, and tight fit. And it has 1 mm pitch, and for the EZ 400 model of the CNC router, this screw is a 6 mm pitch. This slide is small. I need to fit a Lima 17 stepper motor. So you may think that the actuation force is less for this motor, these small motors, as compared with the largest Lima 23 stepper motor, which is on the CNC router. But when we consider it has only 1/6 lead screw pitch of the CNC router, that means it can exert 6 more power or force than the CNC router machines lead screw when they use the same type of motor. So even though this is small motor, the pushing force of this is quite high. I originally purchased this actuator is not for that purpose. I intended to replace the EZ slide on my self-made EDM machine. EDM machine is electrical discharge machine. The EZ slide, I want to use this to replace the one on the EDM machines, but I didn't do it for a while, and it came up to my mind that I can use this to make a EZ slide for my CNC router machines at the rear side. After making these EZ slides, this whole assembly can be easily dismounted from the CNC router, so the whole EZ slides can be used in futures for my other projects, except the such I mentioned that the EDM machine, in the near futures I can make a 3D printers. I can also use this whole Z line assembly as well. Now let's look at the other parts I made this for this slice. Firstly, there is the back mounting place for the linear actuator. As you can see, there are 6 screw holes there, and I need to put on 6 screw holes here as well. And there is a recess area at the center. So I make a small rise up here. So when it slip on this rise up and the groove on the groove and the rise up fit together, this whole line is in a rigid position, and I don't need worry about its assembly position, if it is correct or not. And also there are 6 M6 screw holes there. There are 2 mounting positions on the machine. When I put on a normal position, I use these two screws, 1 and 2. When I put it in a lower position, there's whole slide going down. I use this and this. You will notice that for location purpose of this whole assembly on the back plate, there are dowel pin here. Also there are three pieces. Every time in mounting, I use only 2. I choose either these 2 or either these 2. And I will use back the crest spindle on this rear Z line. So I make the same spindle mount. This spindle mount just a replica of the original one. And what's more is there is 2 more locating hole that's fit for the 2 dowel pin on another bracket. You can see this. And use 2 M6 screw to assemble them. This is another bracket. It's a sliding bracket. It fits on the Z line here. It uses 6 pieces of screw. There are 6 screw holes here. This 4 screw hole is M3, and while this 2 is M2.5. pocket area just fit on this sliding block. And you observe this, there is also recess area here. This is because the sliding block will go to here, and I need to make the keyring area for this portion. So this recess area to make room for this area, this portion. And the final piece is the step motor mounting piece. There are 8 holes on here, 8 holes here, and I choose to use this 4 hole to mount the linear actuator on the step motor bracket. And this, I also make it wrong this at first, so I make more hole there. Anyway, I first assemble the step motor first. This hole exactly match the stepper motor bushing flange, and use 4 screws to assemble it. Yes. Here there are 4 screw holes. We put 4 screws here to assemble them together, and that will complete the job. Now the recess line already assembled. And you can test it. Here, you connect the wire. In the last part of this tutorial, we will introduce the stepper motor driver for this recess line or this stepper motor. You can see it's moving. Okay, I'm now putting it on and use the screw to assemble it. It's now assembled at a lower position. It's using these 2 dowel pins. Otherwise, I can put it here. The normal position is here. Anyway, I need to move this pin here and take out this pin and use these 2 pins and these 2 holes. Now I and assembly at a lower position. The screw is here. Another use of this rear recess line is for producing a large parts. If you have a large piece that occupy almost whole area of the T-slot table, then the first half you can use the front recess line to do the job at first, and the later one, and at a later time, the rear part you use this rear line and take the spindle out and put it on. Installed the rear recess lines, we need to know the relative positions between the front and rear recess line. And let's see this diagram. This is the milling wires which is located on the T-slot table of the CNC router. We clamp a aluminum board on the wires, and we installed the milling cutter on the front spindle. We choose these two edges touching edges, and we bring the front spindle milling cutter and touch here, and we get the Y data, and we drop it down as a Y front. And then we swap the spindle on the rear and bring this rear spindle cutter and touch here again, and another is the Y rear, and the difference of these two data is the Y offset of the front and the rear recess line. This is the difference value, and in my router machines I get this data is minus 0.93. This is millimeter. And in the same way, we are now doing the x-axis again in the same way. We use these touching edges. First we bring the front spindle cutter and touch here and get the X front. And then do it similarly, bring the rear spindle cutter, touch here, you get the X rear. And the differences of these two values is the X offset. And in my machines is the minus 15.115. And we need to remember and record down this data on our notebook for future use. And this data is very useful when we look at Mark 3 So every time I machining the front portion of a large parts, I set up the origin. Use G155 as work table for the front and set up the front, such as we make it as a 0 and Y as a 0. Then we go to the rear fixtures and we set here is a x is minus 15.115, y is minus 0.93. So after we machining the front portion using the front work table, you can continually to use the rear spindle, decentralized spindle to cut the rear part without worrying about the origins or machine data, as we already located it, and we can still use the same CAM file or use our CAM file's origin. Didn't need to be changed. So we will do the works conveniently. The next time I will show you how I will use them to fine machining the little groove here for using as a guiding grooves. See you next time in next video. Thanks for watching.